Good morning, friends. Today we're going to talk about one of my favorite things, extremophiles. Extremophiles are creatures that can live in conditions that once we thought were absolutely impossible to sustain life, in conditions that are super hot or super cold or have a huge amount of salt in them or a huge amount of acid in them, all sorts of ways that we would find life to be impossible. Other forms of life have managed to survive, and we call them extremophiles, because the root philo is from an old Greek word meaning the love of. So extremophiles are creatures who seem to love extreme conditions. So I'm going to tell you the story of one particular extremophile, and in order to do that, we have to go back and talk a little bit about our earlier lessons on the composition of the earth, the way the earth is formed. So I have a chart that I made. It's a chart we had at school, but I made one here at home. And this is talking about, it's looking at a little further detail into the layers of the earth. And this place where you see plastic mantle, that's not because there's a layer of our earth that's made of plastic. If you remember Miss Gael's lesson from last week, she was talking about types of solids. This solid is a plastic solid. It's not made of plastic, okay? So basically what we have here, the blue represents the ocean. And we're going to talk about the sea floor. The sea floor is made up of two main kinds of rock. I mean, there's lots of stuff down there, but the primary two forms of rock are granite and basalt. Granite and basalt. And as you know, our earth is covered with plates that sometimes bump into each other. Well, sometimes these layers of rock kind of rub up against each other, the basalt and the granite. And as would happen with liquids, the lighter one will push on top and the heavier rock will push down. Well, the basalt is the heavier rock, so it pushes down. And sometimes it pushes down into the plastic mantle of the earth where the barosphere is. Remember when we talked about the barosphere? The barosphere is that heavy ball of molten lava and rock and mineral. It's super hot down there. Well, sometimes the basalt in the sea floor pushes down in and kind of pokes a little hole in there, and it allows heat and pressure to come up through the sea floor like this. And we call a place like this a subduction zone. Sub means under. It's a subduction zone. And different things happen when subduction zones occur. Okay, I'm going to tell you the story of what happened in a subduction zone near my home in Oregon in the United States. Move this aside. So about 20 years ago, maybe 25 years ago, some researchers in an area called the Puget Sound, which is just a couple hundred miles north of where I live when I'm in the States, and they were deep sea explorers. And they were really interested in what was going on in the seafloor in Puget Sound, because the Puget Sound is a whole bunch of subduction zones. There's lots of plates pushing down. And subduction zones cause something to happen. They cause minerals and things to come up from the bowels of the earth. And sometimes what they do is they form these sort of chimneys, these mineral chimneys, and they build and build and build and build. Well, these researchers decided that they would go down and try to remove one of those chimneys and bring it up to their lab to study it. So first of all, these minerals are super, super hard and durable. So you can't just go down there and whack it down. They had to develop a special saw that was made of the hardest substance we know of that we can use. Do you know what that is? The saw had a diamond blade. There was a diamond in the blade. And the diamond blade was used on a saw with a robotic arm. So what they did was they went way deep down to the sea floor. And they got this robotic arm to grab a hold of the chimney, and they got this robotic diamond blade saw to chop it away very, very carefully. They didn't want it to shatter. And then they brought it out and they took it to the laboratory. Well, This place where the chimney had been was this fiery furnace of yucky chemicals and heat and so much pressure because it was so far down the bottom of the earth. They didn't really think that any life could live there. But as they started to examine this chimney, they discovered a special microbe that was living. And they were really surprised that it could be living under these conditions. So they decided they'd like to study it a little bit more. So what they did was they wanted to see, you know, they could see that it lived in pretty hostile, unfriendly conditions. So they wanted to see, well, just how unfriendly can we be to this little guy? So they boiled him. They put him in boiling water, this microbe. And what they found is it didn't kill him. In fact, he seemed to kind of liven up a little bit, get a little more active. So they thought, okay, what can we do next? They put him in an autoclave. An autoclave is a machine we use to sterilize surgical equipment. It gets super, super hot, so hot that it can kill everything on the surgical equipment and make it clean for the next patient. Well, this microbe loved the autoclave. He seemed like he was having a great time. He was getting kind of active, moving around. So they continued to increase the temperature on him little by little bit. And they discovered at 121 degrees centigrade, that is 250 degrees Fahrenheit, that this little microbe started to reproduce. He was so happy under these conditions, he started to make more like himself. So the researchers thought this was so interesting because before this time, we thought no life could exist on the earth when the earth was that big molten mass of volcanoes and toxic stuff we've been talking about all year, right? Early on. But it turns out that life could exist a lot earlier than we thought. So now researchers have been going around the world studying extremophiles. And I have put together a little presentation of pictures to show you. So I'm going to share my screen to do that right now. Let's do this. Okay, so extremophiles. There's the word extreme, and there's the phile from philo, to love. These are crazy creatures living in harsh environments. So harsh environments can be created by different conditions. Sometimes it's a lot of high mineral or acidity in the right below the Earth's surface. Sometimes it's the opposite of acidity and it's alkalinity. But these conditions do not look very friendly for sustaining life. Sometimes the conditions are super, super hot. Sometimes the conditions are super, super cold. Whoops, sorry, I went too far. So this is a place where a subduction zone is creating underwater vents, and you can see the hot stuff coming up from underneath, like teapots sending out steam. And then sometimes those vents, oops, this is a deep sea submarine, sorry. This is one of those deep sea submarines that can go way, way farther down, can go almost to the bottom sea floor, which we've not been able to do before. And later on in these pictures, I'm gonna show you some crazy creatures they found. First, I wanna find, here we go. This is an underwater chimney. You can see to the left, you can see the steam coming out, but to the right, you can see a chimney beginning to form. The minerals are gathering and collecting and accruing and building on each other. This is the little microbe they found on the chimney. This is the little guy. They called him strain 121 because 121 degrees Celsius is the temperature at which he started to reproduce, at which he seemed really happy. Okay, now let's see if we can find our next slide. Most extremophiles, just so you know, are microscopic, and that's why we didn't know they existed for a long time. It wasn't until we were able to develop the technology that allowed us to look at tiny, tiny, tiny things that we could discover so many more forms of life than we previously thought existed. This is an extremophile, and that little measurement shows you that that little line at the bottom, that's 1 millimeter. 1 millimeter. So if you look at your ruler, those are those little tiny, tiny lines together. So you can imagine how small this guy is. This is a tardigrade. Now, this is a really incredible little guy. First of all, this is a blown up picture. He's super, super tiny. And if you look at him, he doesn't really look real, does he? He looks like a little plastic guy with funny little mouth. Anyway, this creature can reduce his moisture to 3% of what he needs to survive. So right now he's fully filled with moisture, but he can live, if his environment dries out, he can survive down to 3% of his moisture. And then all it takes is one drop of water to send him out and fill him up again and make him active and living again. They call them, there's some other words for them. One of them is water bear. These are giant tube worms. These guys live so deep in the ocean, they have no access to light. There's no light. It is so dark, and there's incredible pressure on top of them. Think of all the weight of all that water on top of them. There's other really strange guys down in the deep sea, like the frilled shark. He looks like a dinosaur still, doesn't he? Look at his teeth. Look closely at his teeth and the way they are arranged in his mouth. Another deep sea creature is the anglerfish. Now, this guy lives without light too. And this picture doesn't show it, but if you see this sort of protuberance here, it leads to this little thing that hangs over his head, and it's a little light, it's a lure, and it attracts little creatures towards it. And then he swallows them up. Okay, this guy's really weird. I know, the goblin shark. If you can look up a video of the goblin shark eating, it is pretty incredible. His whole mouth just goes like this. It just becomes 3 times as big. And look at those teeth. Now, you don't have to worry about running into one of these guys. He lives super, super deep in the ocean. We didn't even know he existed for a long time. Then there's all sorts of other types of creatures down on the deep, deep sea floor. And we have to wonder, how do they survive with all that pressure and no light? Now, there are follow-up ideas here for working more with extremophiles. So you could write a story about a person or a creature who lives in extreme conditions. So I put some examples here. The girl who lived in the barosphere, I actually had a student write that story once. A 6-year-old child in my class wrote a story after the composition of the Earth lesson about a girl that lived in the barosphere and what she had to do to adapt. Also, the penguin who lived inside a volcano. That's another idea. You can think about what type of adaptations would be necessary for someone to live in such an area. You can also invent your own creature. It doesn't have to be a real one. Just think about an intense, like a really, really cold or really, really hot, some sort of extreme conditions, and then think about what a creature would need to adapt or develop in order to survive. You can illustrate or make a diorama of your story. Another idea is you could make a model of a subduction zone, like our chart here. You could make layers. You could see how you could make a lighter layer and a heavy layer and show how one cuts into the other. Maybe you can figure out a way to release a little steam from, like, making it look like heat and chemicals from the depths of the earth. Who knows? You could write an extremophile poem or song. So using information that you learned from this lesson or from your further research, you could write a poem or a song or a rap about all extremophiles or about one particular type. You could do haiku or diamante. If you don't know what that is, look it up. Rhyming couplets, that's just 2 lines that rhyme. You could do a series of rhyming couplets. You could write and perform a skit. You could develop a skit about one or several types of extremophiles, and you could even work in a small group with your friends, each of you taking one. You could write a simple script. You could design and create some simple costumes. Think about how this creature would move, and then you could perform it and record it. Now, this is for some of our older children. You can do further research. Now, this will require a computer, but there are different types of extremophiles, and they're going to be listed on these next 2 slides. And then I will be putting this, this is in your classroom, so you can look at it again. I'd like you to find examples of each kind of extremophile that's listed. You can draw, or you can make a model, and you can describe, you can label them. Okay, so here's the types. So there's acetophiles. These are organisms that love highly acidic environments. There's halophiles that are organisms that live in habitats that are extremely high in salt. There's hyperthermophiles. They thrive in environments with extremely high temperatures. There's secrophiles, organisms that survive in extreme cold conditions, extremely cold. There's radiophiles. These are weird. These are organisms that thrive in conditions that have a lot of radiation. It's almost like they eat the radiation. There's barophiles. These are organisms that thrive in high pressure environments like the deep sea habitats. We looked at a lot of barophiles in our pictures. There's xerophiles. These are organisms that can live in extremely dry conditions. That would be like the tardigrade I showed you. So I hope you enjoyed learning a little bit about these strange creatures. I would encourage you to do more research, draw them, think about them, invent your own. I am sure there are many more extremophiles living on our planet than we have yet to discover. Maybe someday you'll grow up and you'll discover a new one. All right, thanks friends. Let me know if you have any questions or need any more resources. Have fun with this one.